Hi, my name is Ethan and welcome to Easy Math. Today we're going to look into a few questions from physics and paper 2, that is objective kind of questions. And let's see. So here we have a magnet which is moving into a coil. And because of the movement, we see a deflection in the galvanometer, which is towards the left. Well, it's because there is an EMF generated in the coil when the magnet moves in or out. Well, to understand why this deflection comes about is a different scene that requires different explanation. But what we want in this question is to choose one of these, A, B, C, and D, which produces the same effect, that is a left deflection on the galvanometer. So we're going to see. One has to know, if you see south moving in to the coil, it's nature's law, every action has equal and opposite reaction. Well, to oppose this motion into the coil with the south moving in, the coil is also going to produce a virtual bar magnet inside of it. Well, that bar magnet is going to have a south pole on it on the left side. Why? Because it wants to oppose the south moving. Because there's a south now, there's going to be a north up here. Well, that's a virtual bar magnet, which is going to be induced in the coil. Because of that, you see some deflection happening in the galvanometer. There's going to be an EMF generated. Well, all we have to do now is to look for the arrangement which produces the same virtual bar magnet inside the coil, meaning south should be on the left and north should be on the right. So let's see. There you have a south moving out. When the south moves out, the bar magnet is going to generate a north here. Why? Because the south should come back in. That's equal and opposite reaction. So north here, south there. Have a look here. North moving out. Well, for the north moving out, the bar magnet is going to have a south over here for it to come back. Look at the other one now. This one. Here, the north moves in. If the north moves in, we're going to have a north generated here and a south generated here. Well, if there's a north here, obviously there's going to be a south there induced. Okay. So we have south moving in, there's a south, north, south moving out, there's a north, south, north moving out, there's a south, north. And with the south moving out, there's going to be a north generated here because, again, this bar magnet wants to attract the magnetic bar back into the coil. Equal and opposite reaction. Well, I see out of all the options I have, only this one matches with the orientation of the poles, and that is why the answer should be a D. It will produce, this arrangement will produce the same deflection on the left as it did over here. So a south moving in or a south moving out produces the same deflection. That is why the answer for this one is D. That's question number 35. Now let's go and look at the question number 36. Well, here the input for this transformer is a 240 and the output is a 15. Let's find out the ratio. It's a 240 by 15 comes out to be a 16. Well, all I want to do now is to look for a transformer which has the same ratio on the number of turns on the coils. See, you've got 840. The ratio is 20:1 between the input coil and the output coil. Primary coil and the secondary coil. 1025, the ratio is of 40:1. Here, the ratio is 160:1. 2400 by 15. 800 by 40. 1200 by 75, the ratio here comes out to be a 16:1. This is the only transformer which has the same ratio between the number of turns on the coil and what we were given as the input voltage and the output voltage, and that is why the answer should be a D. The formula that I've used here is N2 divided by N1 equals V2 divided by V1. The ratio of the number of turns should be equal to the ratio of the voltages. Input, 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 and input. That's how it works. That's why the answer should be a D. Okay. Now let's look at the question number 37. 37, you have a magnetic field which is pointing towards the right. You have current which is moving into the page, and you're supposed to find out the direction of the force. Well, this you're going to use left hand rule. Fleming's left hand rule is going to help here. Whenever it comes to finding out the force in presence of a pair of magnetic field and current, you'll always use the left hand rule. Whenever it comes to finding out the direction of the current in the presence of some force moving a current carrying conductor and magnetic field, you're going to use the right hand rule. Well, this situation is that of motors. Motors are supposed to produce forces. This situation is for generators. Generators are supposed to produce current. Whenever it comes to motors, you use the left hand rule. Generators, you use the right hand rule. Okay, now we go use our left hand for this one. How do we arrange them? Well, we're going to have to arrange the fingers on my left hand in the same orientation as they have in the question. So we go look for the magnetic field. Well, magnetic field is supposed to be this finger, first finger. So you go, this one is supposed to be F, this one is supposed to be B, and the middle finger is supposed to be I. They should be perpendicular to each other, if you can see. Perpendicular, perpendicular, and of course, they are perpendicular too. Okay, so here we go. We're gonna, this is supposed to be B. So we go point it towards my right. That's my right. B. I is supposed to point away from me. So I open up my middle finger, should point away from me. With the B still pointing to my right, I see that the thumb, when I open it, points downwards. Can you see it? I'll show it to you again. You go B, there, towards my right. I, away from me, there it is. I've opened it up. The middle finger, and then I go open up my thumb. I see it's pointing downwards. F, B, I. I just had to orient my hand in a way that it matches the setup in the question. F, B, and I, FBI. F downwards. And that is why the answer is an A. Again, I would say whenever it comes to forces, finding out the force, direction of force in the presence of a magnetic field and current, use left hand rule. Trying to find out current, use the right hand rule. That's it. You just have to learn how to use it. And maybe you should do a few practice questions on the left hand and the right hand rule. That's it for today. I'll see you. Only 3 questions we had to do today. I'll see you. Bye-bye.